For this exercise with try-catch, we're going to demonstrate how to add the ability to throw exceptions into your own class. So let's go ahead and get started. The class we're going to work with is a list class that we created earlier. Here's the class. And what we want to do is we want to add the ability to throw an exception when the user tries to use the toString method on an empty list. Since there's nothing to be displayed in an empty list, it makes sense that you could throw an exception saying you can't display this because the list is empty. To add exception throwing to this class, we're going to have to do a few things. Since we're already in the class, we'll start here. If we want a method to throw an exception, we have to tell the compiler that the method can throw the exception. So right here we add throws list empty exception to the method. Now down below in the definition is where we'll actually throw the exception. So what we're going to do, we're going to say if data store sub 0 is equal to null, in other words, if the list is empty, then we want it to throw a new list empty exception. And yes, I recognize that we haven't actually created the list empty exception class yet. We're going to do that right away. But that's all we have to do in the class definition to throw an exception. So it's fairly easy to add that to a class definition. So let's save that. Can't compile it yet because we don't have our exception class. So let's do that next. So we're going to write notepad list empty exception.java. And here's our exception class. I went ahead and defined it earlier just to save a little bit of time for the exercise. The way we do that is we write public class list empty exception extends runtime exception. Any exception that you create yourself has to extend one of the built-in exception classes, and I picked runtime exception. All we need is a constructor so that when we write throw new list empty exception, it will call the constructor. And all the constructor does is goes back to the base class, to the superclass, and calls the constructor for the runtime exception class along with the message list is empty. Let's put a period right there. And that's all we have to do. So let's save that. Go back to our command prompt and let's compile it. And it compiles just fine. Now we're ready to test our exception. So here's our program to test the exception. Again, I went ahead and wrote it up in advance. The program is called namelist, and all it does is it instantiates a new list, and then without adding any names to it, calls the toString method. If there are no names in the list, then it will throw a list empty exception, and that's caught right here. Our object is E, and we have it called the print stack trace method for exceptions. And all that does is displays our list is empty message along with line numbers for where the exception was thrown from. So let's compile that. Then let's run it. And there's our exception thrown. List empty exception, list is empty. At list to string, line 20, at namelist, line 5. So the stack trace is useful for debugging purposes if you want to see where exceptions are being thrown. Now, it's not all that useful to the user, and in a real program, of course, we would present a message asking the user to go back and enter some names into the list before trying to do a toString. But for the purposes of this exercise, I thought a stack trace might be nice just to see how it works. So to review, you create a exception class of your own design that extends one of the built-in exception classes. Then in your program, at some point you will throw an exception. So here in the toString method is where we threw the exception. And then in the program that will work with the exception, you'll have to catch the exception at some point to make it worthwhile to do the design in the first place. So that's how you create your own exception classes. And with that, we're finished with this chapter on exception handling.